Hello, Year 3. It's Mr. White here again to give you your third maths lesson of summer term week 3. And this week we've been looking at place value and measuring. And today we're going to do some problem solving based on measurement. If you remember, we are looking at millimeters, centimeters, and meters. And from the last lesson, we all know that every 1 centimeter is 10 millimeters. There are 100 centimeters in a meter, and therefore a 1,000 millimeters in a meter. So hopefully you've got that, and you can use it when trying to do these problem solving issues. So you remember, when you're problem solving, you need to read the question really carefully, maybe underline the key bits and the key words, and work out exactly what the question is asking you to do. When you've done that, and only when you've done that, you can really then look at what the answer might look like. Is it an answer in centimeters? Is it a comparison? So you have to think about, if that's the question, and what's the answer going to look like? What kind of answer are they going to need? And then you have to look at the various steps you need to take in order to get to that answer. So once you've done that, then you take the steps, and then you can maybe use the inverse to check your answer, etc. So remember, problem solving is a step process. It's a process. It's very systematic. It's very simple. Read the question carefully, underline the key bits, work out exactly what the question's asking you to do. What's the question asking? Then think about, what is my answer going to look like? Is it going to be a number in centimeters or meters? Is it going to be an explanation? And then how am I going to get there? And when you've done those steps, then you get onto the maths and try and work out, and then you write down your answer, and you write out your answer. And if you show you're working out, it is really clear when you go back to look at it how you've done it. We could see what logic you've used and how you've got there. So that's it with problem solving, and I know most of you are getting much better at that. So let's see how you get on today. So first question, and let me just get myself out of the way so you can read it. Rajan says, if I need to add 2 meters and 45 centimeters and 290 centimeters together, the only way to find the answer is to convert the first length into just centimeters. So do you agree with Rajan, and explain why? So if you look at this question, it's saying, do you agree with Rajan, and explain why? So the first thing you've got to do is, yes, I agree, or no, I don't agree. And then you've got to use your maths to explain why. And the question is, he's trying to add 2 numbers together. One's in meters and centimeters, and one's in centimeters. And he's saying that the only way to do it would be to convert the first 2 meters 45 centimeters into centimeters. Is it the right way? Is it the only way? Is there a different way of doing it? See what you think, explain your answer. Now the second one is true or false. So your answer is going to be either true or false. But remember, when you're doing it, think about why you're doing it and show me why you think your answer is what you are. So to add a series of measurements together, it's best to convert them first so they're all in the same unit of measurements. Do you think that's true, or do you think that's false? And why do you think that? So question 1, 240 centimeters plus 2 meters equals 242 centimeters. Is that right, or is it wrong? So is it true, or is it false? And whichever you answer, why do you think it? Show you're working out, show you why you think that. 3 meters and 15 centimeters plus 310 centimeters equals 6 meters 25 centimeters. True or false? See if you can work it out. And then the last two, 145 centimeters plus 2 meters 8 centimeters is larger than 3.5 meters plus 13 centimeters. So you've all done lots of work on fractions. I've seen some fantastic work on Tapestry using fractions, and you're going to need your fractions here, because what is half a meter? How many centimeters is half a meter? Knowing that 100 centimeters is 1 meter. So what is half of 100? Big clue there, and you should manage to get that one. Now, finally, 9 centimeters plus 1 meter equals 100 centimeters. Is it true or is it false? And show me your answer. So those are quite difficult ones. You're going to have to think about it. So pause the screen, do the maths, stick it on Tapestry. Right, welcome back. Let's look at the next series of questions. 4 friends are building towers. Eva's tower is 22 centimetres and 7 millimetres. Teddy's tower is 22 centimetres. Annie's tower is 215 millimetres. And Dexter's tower is 260 millimetres. Now, what it wants you to do is order the children's tower in descending order. If you think descending is going down, descending, so it's getting smaller. So you put the biggest one first and the smallest one last. Now, if it was ascending order, you would put the smallest one first and the biggest one last. So you have to be very careful with your terminology here. And obviously, I think here you might just want to convert them all into 1 unit of measurement. So maybe you're going to convert them all into millimetres, seeing as the 2 at the end are already in millimetres. That's a very big clue. Be very interested to see how you get on with that one. Pause the screen, have a look at it, see how you get on. Welcome back, and finally, here is another maths question, and this is all about 4 children in my class. So it says that Stanley is 1 metre 30 centimetres tall. Now, I don't know whether he is, because I haven't seen him today to measure him. Saskia is 1 metre and 38 centimetres tall. Now, funnily enough, I know that Saskia's that length because she's in with the key worker bubble, and I went and measured her before making this video. So we all know Saskia is actually 1 metre 38 centimetres tall, and I know that Bartosz is 1 metre 31 centimetres tall because he's also in school today. Now, Simi, I really don't know because she's not here to measure, but I've estimated that she is 128 centimetres tall. So, can you order them in ascending height order? So you have to remember what ascending means and put your answers there. So once again, maybe you want to convert them all into the same unit of measurement and then put them in. So that's your maths challenge for this week. I hope you've enjoyed revising measurements, and I look forward to seeing you soon. Oh, and if you really wanted, here's one more maths question, but this one might be a bit difficult. So this one is a real challenge for those maths geniuses in year 3 who really might want to do it. So see how you get on with that if you really are a maths genius and want a real challenge. Remember to put your work on Tapestry.